Hello again, class. We have a fantastic topic for today. We are going to talk about image compression using machine learning. The first thing we'll have to do is try to understand how images are stored inside files. So we know that there's a lot of different file formats. We have JPEGs, we have PNG files, we have TIFF files. Generally, they all have a fixed number of pixels that are going to be displayed. And that is simply going to be the dimensions of the picture shown. So for example, we have n number of pixels in a file here, where n is the width times the height. So for example, if we have a 300 by 400 pixel file, then our file has 120,000 pixels in it. So each pixel simply represents a dot on the screen. So each pixel also has a color, and we have a couple options there. We have a couple different formats. A common one is RGB, and RGB stands for red, green, and blue. And that's also known as true color. So in that case, we actually have 24-bit color, and that would mean we use 3 bytes per pixel. So there would be a byte to store the red value, a byte to store the green value, and a byte to store the blue value. So we have a byte, a byte, a byte, and that gives us 3 bytes, and that is 24 bits. And of course, the biggest 24-bit number is going to be 16,777,215, right? And so we have that 216 colors, right, to choose from. And that is a lot of colors. And it turns out that given a picture, we don't necessarily need that many colors. For example, look at this slide. How many colors do we have? Well, we have white right here, we have green, we have this color blue, we have this color yellow, we have this color blue, we have orange, and we have black. So we really only have about 7 colors in this image shown to you on your screen. And for this, we don't really need to choose from 16 million different colors. But in any case, if we did have a file with a 300 by 400 pixels, we would have 120,000 pixels, 16 million different colors. Our file size would be roughly 360 kilobytes. Okay, so that's bytes. And all you have to do is multiply 120,000 by 3, and that gives us the number of bytes right there. So there's lots of different ways to compress files in general, but what we're going to focus on for this image compression is, first of all, we want to reduce the file size, right? And we also want to keep the dimensions the same. We don't want to just shrink the image down and remove the number of pixels. What we want to do is make each pixel store less information. So how can we make each pixel store less information? Well, we can reduce the number of colors. And what we want to do is make less storage per pixel. So we can store a number between 0 and 16 million essentially, right? And that's divided into 3 parts. the red, the green, and the blue. So if we're going to have less storage per pixel, we would have less colors to choose from. And this is essentially image compression by color reduction, right? So we're going to choose the maximum number of colors that we can actually use. So maybe we'll make it 100 colors we can choose from instead of 16 million, or we'll make it 50 colors or 5 colors, right? And then what we'll do is we need to assign every pixel one of those color choices. So if we want to reduce our color choices to 10, every single pixel in the whole entire image must choose from one of those 10 options. So I'll show you a couple of examples I did right here with some image reduction. Sorry, with color reduction. So this image right here shows a picture of a dog. The original image is on the left side, and the compressed image is on the right side. So this was reduced down to 20 colors, and I did use machine learning to do this. So let's take a look and see what we have right away. First of all, we can see that the dog over here doesn't look too bad. However, the tongue looks not quite as pink as it does over here. And we also know that the background, now this background is blurred on purpose. And this is a photography technique called the bokeh effect, and it's where you put your foreground object in focus and you have your background out of focus so the image pops out more. So this is the true original image here. Now if you notice that over here that this definitely got distorted. So you can kind of make out a tree over here, but you can see this got distorted. Over here we have, this is actually a brick wall, like kind of a decorative wall. And of course over here we can see that got reduced pretty heavily over there for our color reduction. And what happened is it's very extremely grainy over there. So the next thing we'll look at the same image, and this time I reduced it to 6 colors. So here's the 6 color image. Again, you can still see that it's a dog. Absolutely, it's a dog, no doubt. Our background is pretty much gone. Right? So there's really no way of telling what this is over here. The dog itself, you can definitely make out that it's a dog, but you can see at least there's enough color choices shown through here that we can determine that it's a dog, and we can see the different shades, right? We see some dark shades over here, and we see some of the browns there. I feel like John Madden, right? Boom. In any case, we can also see in this part of the image that it completely turned almost all to one color here. Okay? But again, this is only 6 colors that we can choose from. So this entire picture of the dog right here is only 6 colors. So let's look at the next one. We reduced this thing down to 2 colors. And you can probably still tell that it's a dog, But unfortunately, the dog's nose, or most of the nose, is also the same color the background, right? So if we just showed you part of the image, it might be a little bit hard to tell, but looking at it now, you can probably still tell that it's a dog. And if we only have two colors, it's essentially monochrome. So we need a way of figuring out what the 20 colors would be for this image and what the 6 colors would be for the next image and what the 2 colors would be for this image. So notice that it picked sort of a brownish color here that's kind of light and a sort of a greenish brown color there, right? Because we have a lot of browns in here, and then we have a lot of greens, right? We have all of this background green, we have all that background green, we have all that background green. The color of the dog's nose is black. So it's looking like it picks some kind of average color that's sort of a green, black for the background here, and some sort of brownish color for that part. So how can we actually pick these colors? Well, we can actually use AI, and we can use clustering for this. So we're going to use k-means clustering like we learned previously. And K in k-means clustering is the number of clusters that you want to have. So for us, K is going to be the number of color choices, right? So for example, 6 colors. So if we want to compress our image down to 6 colors, what are those 6 colors we actually want to choose? Then what we're going to do, we're going to perform a 3-dimensional cluster where each dimension is one of the colors. The red dimension, the green dimension, and the blue dimension. And it turns out that we can actually still visualize this. Remember, when we have multi-dimensional clustering, it gets very difficult to visualize it. But we can plot a 3-dimensional cluster pretty easily. And I'll show you an example here. So consider this Van Gogh painting, right? This painting is Starry Night. So what does it look like when we plot each of these along these axes? So we'll say this is the blue cluster. So down here, this is less blue, and this is very blue up here. Okay, going this way is less green up to here, which is very green. And of course, this way is, oops, sorry, wrong way. Go back here. So this way is more red going that way. So first of all, let's take a look at this picture. What colors do we see in here? Well, obviously we see a lot of blue. Right, so in here, of course, we have lots of blue colors. Even though I'm writing it in red, we have pretty dominant colors in blue, a lot of black, a little bit of yellow here and there, and we have no reds, other than maybe a little tiny section right there has some reds in it. Obviously, some of the color tints have some reds, but again, if we look at this, we see most of our pixels are clustered toward the back here. So going this way is the red dimension, and we don't see a lot of things up in this area, right? So anywhere up here. Most of our pixels are going to be way back toward this area because we don't have a lot of red. Now, we do have a good bit of blue values, right? And again, we have many values, you can see a lot of these blue colors right here. So this is simply what it looks like when you would plot this in 3 dimensions. If we could rotate this thing around, we would kind of get the gist of it more. But I just found this image online and included in here. So this image I did not create. Obviously I didn't paint this, but I didn't produce this 3D plot. So what we would want to do next is try to find clusters. So I'm just doing an example here, showing you how we might find clusters. Maybe over here we have the dark greens cluster right here, right? And I tried to draw some circles here. And then we have maybe some dark blue clustering here. We have some light blue clustering here, and we have maybe some oranges over there. And again, we don't really see any dominating clusters of red. So the reds just might end up having to be included in some other cluster. So how are we going to use k-means clustering? Well, if we find the middle point of each of these, right, all of these clusters here, right, maybe we take that pixel, we take that pixel and it becomes our new color. And this is going to be explained in the next slide here. So for example, if we look at the clusters of blues, okay, maybe we're looking at this cluster right here, right? And we have all of these different colors, right? Maybe all of these different colors are in the blue cluster. Well, guess what? All of these will become this color. So the centroid of each cluster is going to be the new compressed color. So each pixel in the color becomes that new color. So every pixel in the cluster now becomes this one single color right there. So all of these pixels here are going to become one new color. All of these pixels are going to become one new color. And what color is going to be chosen? Well, the centroid of the cluster. Again, this is a good example because it's easy to visualize it. So for every cluster that we have, we simply pick the new color and then we replace all the pixels in that cluster with the new color. So how can we actually code this? Well, we can look at how we would do this inside Jupyter Notebooks. So the first thing we would want to do is be able to read in an image file. So to be able to do that, you would have to have an image file in your project. Okay, and we covered how to do that. And we can read the file using matplotlib. Okay, so right here, we can see we can read the file right there pretty easily, right? And we have something called a shape, right? So we have a shape right there. Now a shape doesn't refer to anything really as far as images go. It's simply something used in NumPy. And the shape is going to be simply the number of dimensions. So when we say print the shape of this, it's going to print the number of dimensions that it read in. So it reads this file in as raw data, and then it will just print out what the shape of it is right here. So it turns out that it's not really in a good format for us to use. What we want is we want an array with an RGB value in each element, right? So if we have an array here, right, that represents all the pixels in a file, we want every single array element to be an RGB value. RGB value here, we want an RGB value here, and so forth, right? So this thing right here shows you maybe what the first 3 elements of an array would be, right? And then they would be filled up with every pixel. So what this does is this line of code will reshape this so that our raw file that was read in kind of gets converted into an array of 3 pixel values RGB. And then I show you what it looks like when you print that out. It looks like this. Next, we would want to actually use k-means clustering on that data. And what that would do is it would cluster the points and find the color clusters. We would obviously see the previous lecture slide on how to do that. And the centroid is going to be your new color. Now, I will warn you, this step will take a lot of time. The more number of clusters you have, the longer it's going to take. So 2 colors might not be bad, but when you try to do 20 or something like that, it's going to take a while. Why? Well, because we're using the free Jupyter notebooks, and it has very, very, very low processing power. If we had it on a real virtual machine or a better plan, whatever, it would go pretty fast. So don't be surprised if this takes several minutes once you do that. So after we would perform k-means clustering, right, we would have the centroid color. And what we would want to do is go ahead and compress the image. And to use that library, we're just going to put this in here from scikit-learn.cluster import k-means. So all that's going to do is give us the k-means clustering library. All right, and it'll pull that in. We're also going to use pandas in order to make what we call data frames. So I could put this in again. I don't need to. It would just kind of redefine it. I don't need to do that because I already imported it above. So what I can do, I need to get this in a format called a data frame so that we can actually analyze it properly. So this is what we're going to do here. I just call it DF data frame, and it's PD, which is our pandas library. And what I'm going to do, I'm just going to pull out the price. That's it. So I could print this. Oops. Right, and we get this thing here, and I just get all the prices, right? Well, almost all. It puts the dot in there. Right, so it might be better just to say df.head there, right? So it looks like it's in the right format. The next thing I do, I kind of like make an instance of the k-means object there, and I'm just going to pick 10 clusters because, again, I have no idea right now. So if you print that out, it's just really gonna, it's not really analyzing data. It's just showing you what the properties are of this thing right here, right? And we can just, look at this. It's not really useful right now, though. So to actually run this thing, let me not print that. To actually run this thing, I would say something like, I'll just call it the clusters are going to equal, let's see, it's going to be this k-mean. And then what we're going to do fit predict right here. K-means.fit predict the price. Let me do that instead. And that's going to create clusters. And again, I could print this out. The clusters. right? And again, you might say, well, that doesn't look very useful. So in order to combine this list of prices and the cluster it belongs to, this is what we can do. What we want the price and a cluster number. And the cluster number is just categorical. Cluster 1, cluster 2, cluster 3, whatever. So we'll just do this. We're going to say, we can call this anything we want here, right? You name it whatever you want. But I want mine to be called cluster number. And now if I would print this out, we can see it clustered it. All right. Now we should see clusters around the same price. Look, the ones around the $80 range are in cluster 6. The ones around the $140 range are in cluster 1. Right? So where are those cutoff points? Well, we can kind of look. Right? And when we plot it out, it'll show us more information. Now, doing a line plot in Matplotlib is kind of challenging. I find it easier to just do an XY chart and then just put the Y's as all zeros, and then it makes a vertical line. I'll show you what I mean. So what I'm going to do, I'm just going to go ahead and add a column into here, right? Because when we do a scatter plot, we need an X and a Y. So I'm going to add another column right here with all zeros, and it'll make this appear all in the same line. So all we're going to do is this. I'm just going to say, go ahead and make a column called Y and print it out. And set it to 0. And now when we print these, we get this, right? We just get this column of zeros, right? So if I plot this, it should just go ahead and put a big horizontal line there. So I want to plot this thing, and we would have to plot it. We use Matplotlib again, and I can't remember if we imported that. Yeah, I believe we did import that already, so we don't need that. So what we want to do here, I'll show you what the next thing is. Just going to do a scatter plot with price and with the cluster price, and then the cluster number would be Y. So it's really just making a line and putting a dot in every one of those spots there. So again, here they all are. Now, just looking at it, we can see there's lots over here. Okay, now that's not showing us what cluster any of these belong to. Okay, this is just showing that there's lots of them under the $2,000 range. The problem is we're not seeing the cluster number, the 1, the 8, the 6, right? We made 10 clusters. So what you have to do, you have to make every cluster a different color. And one of the tricks I learned to do is to just print this out and just cast the cluster number as a float and let that be the color. Again, there's no real meaning because this is categorical. Okay, but we'll just do it like this. And now every cluster number should be a different color. Okay, so here we have it. Here are our clusters. It made a cluster, I can't tell if that's the same color, but one here, one here, one here. There's a cluster there. Okay, so again, everything seems to be jammed up in this small area. We might want to just reduce, our data set. We might want to just get rid of items that cost over $4,000. What we would do is basically replace every pixel with our centroids that we found. Okay, so this code here will show you how to do that. So this will use the centroids for each of the colors. And essentially, that's going to make an image in memory. It's not going to save it as a file or anything, but it's just going to save our image and replace that image in memory that we have. And what would we want to do next? Well, we'd actually want to see the compressed image, right? So here's some code to show you how to plot the original image and then the compressed image right next to it, right? So you'll have to, you would have to figure out how to do the clustering part, and we covered that part already. So as an assignment, what you're going to want to do is this. You're going to compress this image right here, and I'll show you how to get this image. You're going to compress it to 2 colors, 6 colors, and 10 colors, right? So you're going to obtain the image by simply getting the original image from Google. You can do a Google image search on Pitt Johnstown, and what will happen is you'll find that image pretty easily. So when I go to Google and do Google Images and do Pitt Johnstown, I just pick the very first one I found. So go ahead and grab that. You'll want to write code inside Jupyter Notebooks that actually does the image compression using 2 colors, 6 colors, and 10 colors. And what you'll want to do is go ahead at the end and print the original next to the compressed version. Okay. And then you can do it, you can make a variable if you want for the number of colors, whatever. Go ahead and share that notebook with me and turn in the link. And also, you want to answer the question, what kind of images compress well with little distortion? Justify your answer, and what you want to do is just answer that question in the comments, right? So maybe at the bottom you can make a comment or a heading or something like that, and go ahead and answer that question. All right, class, have fun with this assignment.